start, let's go over the concepts of Wave. Wave takes care of all the work for you. It provisions Kubernetes on the cloud of your choice. It integrates with Ocean automatically. It takes care of scheduling driver and executor nodes on instances that make sense for them, whether they're spot instances or on demand. It automatically sets up an ingress controller. It automatically installs a history server, Jupyter Notebook, Spark Submit. It's compatible with everything you need for a big data Spark application right out of the box. On top of this, Wave comes with a robust console that'll show you all of your Wave jobs, everything that's run in Spark, their cost history, their node history, and their pod history to give you a full view of everything that you're doing in big data in your organization. Wave begins where data scientists, engineers, and DevOps live, at the command line. With some boilerplate YAML and a custom cluster name, it's extremely easy to get started with spotctl, a command line utility that will take care of all the heavy lifting of provisioning a fresh Kubernetes, Ocean, and Wave in an enterprise-supported Spark solution. Now, with the power of video editing, we've condensed some of the provisioning time and Spark jobs in this demo, but you can recreate all of these commands with your own Spark cluster. Now that the cluster is created, we're going to list all of the nodes and pods that make up this environment. As you can see, some of the pods are still creating, but what we'll have when everything is done is a fully functioning Spark environment that will give us Jupyter Notebooks right out of the box and an ability to use Spark Submit to start sending jobs right away. Our Wave cluster is now available, so let's get into provisioning a Jupyter Notebook. Now, we don't just want to show you the Jupyter Notebook interface. We want to show you what Wave is doing underneath the hood. So we're going to split our terminal into two parts. On the bottom, we're going to list all of the nodes and pods that are involved in running the Jupyter Notebook environment. You're going to notice a combination of both spot and on-demand instances. The on-demand node will take any non-interruptible workloads such as the driver, and the spot nodes will take the jobs that are actually provisioned by the Jupyter Notebook when we run them. Now on the top pane, we're going to see all the components that are already installed by Wave. We're going to copy the endpoint of our enterprise gateway, and then we're also going to copy the Jupyter Gateway Authentication. This will allow us to securely connect to Jupyter, which is already running inside the cluster. It'll set up a secure connection back to the laptop that we're working from, and we'll be able to use the Jupyter Notebook without using any local resources and using all of the compute power of the cloud. Now that we can securely connect to the web interface, let's run an example notebook, not only showing what happens in the UI, but also showing what happens on the Kubernetes cluster behind the scenes. As we launch this notebook, Wave is going to help provision the pods in the correct locations inside this cluster. Again, driver nodes, running on on-demand instances, and any worker or jobs that need to be run by the Jupyter Notebook running on spot instances, which is going to give you that infrastructure efficiency. We can very quickly calculate pi, which is a very quick demo in the big data world. We can also step through a bunch of other Panda examples and demonstrate how on the back end, all of these jobs can run as efficiently as possible while you use Jupyter Notebooks the same way you always have. And Wave takes care of actually provisioning and running the infrastructure behind the scenes in the most cost-efficient and optimized manner. Because we closed our Jupyter Notebook, not only did we scale up to match the need of our jobs while we were running the notebook, but Wave and Ocean, the combination of those two, were able to scale not only the pods but the infrastructure back down to zero. Because these jobs are completed, they no longer need the infrastructure underneath. So Wave and Ocean got rid of it. But you still have a full history of what you ran, so you can go back and look at it at any time. Now let's take this up a notch. Our data scientist is done with the Jupyter Notebook and is handing it over to the data engineer to run this at scale. Now we can use the same cluster we used for Jupyter Notebook to run Spark Submit. This time in our terminal split pane, we're going to keep the bottom with the nodes and the pods that are need to execute this job. But on the top, we're going to use Spark Submit natively on the command line, the native open source solution. There's no new front door to go to get the Spark that you know and love. You can take the job that the data scientist gave you and now run that at scale in the cluster. Again, the combination of Wave and Ocean is going to use the same logic to launch both spot and on-demand nodes as necessary, and then place those pods intelligently in the cluster based on their needs. The driver is provisioned to on-demand, so it can run as long as it needs to, and the executor pods are scheduled on top of spot instances for extreme cost savings. Wave will take care of any interruptions and ensure that every job that is scheduled completes. Again, with Spot CTL, it's easy to get the state of any Spark application and a list of any jobs that have run on it, whether those jobs are from a Jupyter notebook or those jobs are from a Spark Submit application. We can get the status, history, and everything that we've done inside the cluster from the command line. Now, running everything through the command line is great, but it's even better if you can visualize everything. And that's why Wave comes with a robust console where you can see everything that's running, from your Spark cluster savings to the number of nodes to the number of applications, down to the currently installed versions of everything that you have running in your cluster. You get a full history of every Spark job that's run. You can see what jobs were successful, which ones failed, over what time period. You can check out the node distribution and the node activity, how many jobs have been running and what type of activity they have been running against the pods on your cluster, and then also the average completion time for all the jobs that you're running. All of this is accessible right in the main dashboard from Wave. Furthermore, a detailed cost analysis of every Spark application that's been run is available in a detailed view dedicated to cost analytics, so you know exactly how much you're spending to run every single job in your big data application. Last but not least, everything is logged. All activities from Spark, all activities from Wave, whether it's due to scaling or how pods land on particular instances or how a job was scheduled and run, everything can be retrieved through the console and also through the API. Thank you very much. That concludes our demo for today. Again, I am Kevin McGrath, CTO of Spot by NetApp, and it has been a pleasure explaining the value of Wave and how you can scale, grow, and optimally run Spark applications for big data workloads in the cloud. I'll remind everybody you can get started for free at spot.io, and we hope to see you join the platform too so we can scale together in the cloud. Thank you.